Okay, so the last part of this lab is going to be with respect to files. The last thing we did with respect to the previous sessions was with respect to loops, arrays, and strings. So what we're going to do here is that we're going to see that file input and output, it works very similarly to normal input and output, such as cin and cout. But there are a few minor added complexities that we need to watch in particular. So basically, the basic file input output classes in C++ are going to be ifstream, which is the input file stream, offstream, which is the output file stream, and fstream, which is both input and output file stream. Now, in order to use this in particular, what we're going to have to do here, so I'm going to clean up my code, we're going to have to include the fstream library. And file streams need to be explicitly set up by the programmer, but it's very simple to do. All you need to do is just instantiate an object of the appropriate file input-output class with the name of the file as the parameter. And then you can either use the insertion or extraction operators to read or write to the file. And then you can have to close the file to make sure that the contents of the file is saved appropriately. So let's say we wanted to set up an input file stream. We're going to name it infile. And then let's set up some other variables here. So let's open our input file. And let's say in this case we have the input file here. Name.txt. We need to do a safety check here to make sure that the file is able to open. So this exclamation is the not gate parameter. And this not gate parameter basically means to say if the logic for this function is the opposite of what it is. So for instance, the function here is named infile.isOpen. But the not operator being the exclamation point means that if the file is not open. So if it's not open, we want to output cannot find file. Else, so the else condition here would be that the file actually exists. So we print out to the screen file found. And then we proceed to read from the file. Now in reading from the file there may be multiple lines in the file, so what we need to do with this to read each line in turn is that we need to set up a loop. So we use a while loop here and say while we're not at the end of file. So the .eof function basically means end of file. So while we're not at the end of file, we want to read we want to read a line from the file, and we want to see what number or what line number we are at. So this is why we have kept track of a running sum. And we want to output the contents of the number we have read from the file. And then, because we've been reading numbers from this file in particular, we can say the sum is, because we're keeping a running sum here, and we output it to the screen. And then for safety, we need to close the file. Alright, so if I compile this, what I'm going to see here is that I didn't create our name.txt file. And if I try to run this program, the output here is going to say that it's unable to find the file. So it'll say cannot find file, which is the safety code we implemented here to make sure that our program exits successfully in the event that it cannot find the file. So in order for us to make sure this file exists, we want to right click on resource items or resource files, and we want to add a new item. And what we want to add here in particular, let's see if I can find this, formatting, data. Right, so we want to go in utility and we want to add a text file. And this text file, as we typed it in our code, is going to be name.txt. So let's put some numbers here inside name.txt. And now that the file does exist and it's going to be included in our project, let's run our program. And now we can see that the file here was actually found. It printed out each one of the numbers or each one of the lines in the file, and it calculated the sum in particular for us. Now this works because we expect to be reading integers from the file. So that's why we end up using these data types here of type integer, being num and sum. Now if it wasn't type integer, meaning that if there were characters inside the file, that means we're going to have to use the string library to read these characters in particular. So now that we've seen how we've read from a file, let's consider how we can read from a file and then write to a file. So we're going to edit the code here a little bit. So we have the input file stream here being in file. We want to create an output file stream, and we're going to name it out file. We're now going to have an output file object here named out file because we created this. And we're going to open it accordingly and give it a file name. So name underscore appended.txt. Instead of using the cout operation here, we can use the out file operation instead. But we're still going to output the sum to the console screen so that way the user can see it. But now we're also going to write what the sum is to our output file. And to ensure that our file is able to be saved properly, we need to call the close function on our output file. Now, note in particular here, for the output file, I didn't bother to create a new text file. And this is because we're dealing with the output file here. So once the program runs, if the file doesn't exist, we'll automatically create this file for us. So let's build our program and let's run it. So our program runs successfully. And now if I right click on resource files and I hit add existing item instead, we can see that here there's a file that has been created that is the same name as we gave it for our output file. So name appended. So if we add this and we double click on it, we can see that we successfully wrote the line that we coded inside here. So basically this line that was output out file, and we said okay, put the contents of this into the out file object so that we is able to write to this text file. This is why it writes to the file and we can see it here appropriately. Now, the question that may occur is, what happens if we write to a file that already exists? So for instance, let's say if I go back and name appended.txt here, and let's say I just add some random nonsense here. And if I rerun my program, so my program runs here, and I close this off, right, so you're going to see here that Visual Studio is going to prompt us saying that the contents of name_appended.txt has been changed. There's going to ask us if we want to reload the file. So we click on yes to reload the file. But when we go back here, we can see that we haven't basically added any new lines to this file. It just rewrites and recreates the entire file from scratch. So the original contents of the file are lost, and it just writes an entirely new file for us, overwriting whatever existed in the first place. Now, in some cases, we may not want this to happen. So what we do here is that when we create our output file, so I'm going to remove this line. Well, no, I'm going to comment this line. When we create our output file here, we can use our brackets here to indicate what we wanted the name to be. So appended.txt. And then we can use a special parameter named std:/ios::app. And what this does, it means that it tells the out file object here, okay, we're expecting to operate on the name_appended.txt file. But the parameter here, which is std:/ios::app, means, okay, set up this file so that we can append to the file. So each time when we write to the file, we're going to be writing a new line to the file for each instance the program runs. So we currently have sum is 27 here. Let's say if we decide to add one extra line here inside our name.txt file. What we're going to expect is that we're going to see a new sum that's been calculated, but it's going to appear as a second line here in particular. So let's recompile our program here. Let's run it again. So we still see that we are able to read from the input file accordingly. And now, because we added that extra line in the input file, we now have a new sum here, which is 35. So when this program exits, we're going to see that name_appended.txt has been edited because of the program. We're going to reload it. But when we reload it here, we're going to see that we're going to have sum is 35 here accordingly. Now, in this particular case, what happened is that I did not include a new line, so that way it showed up on the same line here accordingly. So if I remove this here, and put the file back to how it was, and if I go in my C++ file here and I include an end line character here for when I was writing to the file, recompile my code, and I run it, so we can see the output here accordingly. When I reload my name_appended.txt file, okay, I still have the same problem, so I made a mistake. No, I did not make a mistake. I know what happened. Don't worry. So, let's run the file one more time. And reload this. So now we can actually see that a new line has been generated. So, this original content is when the first time I ran the program, it did not include the end line character because it wasn't there in the program. And as of such, when the next instance ran, it just executed from the previous end of the file, leaving this. But in this case, once the program ran again, it included the new line as a new line because we had our end line character here being outputted. So the start of the file would have been a new line to begin with. And just to prove it one more time, let's take off the 8 here in the input file stream. And let's rerun our program. You're going to see sum is 27 here. Close that off. Reload our text file. And we can see sum is 27 here. And we can also see that there's a fourth line here in particular, indicating that this is where the next line is going to be written to the file accordingly. Alright, so that is it regards to our second lab here. If you have any questions, please make sure that you leave any comments in any of the respective videos, or you can find us accordingly in the lab to ask any questions in particular. Alright, that's all for today.